Hello friends, we have a SMPS which is 750 watts with output of double voltages. We mean that we have a positive voltage and a negative voltage. For example, in this SMPS I made, we have plus 75 volts and minus 75 volts used for amplifiers. I want to teach you a step by step, and I am hkarimi, electrical engineering from Iran. Let's do it. Okay friends, this is the printed PCB and it is going to be etched in ferrite chloride. All the files you needed to print the PCB and top layer is in description. You can download from the description, or if you had any question or any file needed to do your SMPS, please contact me by hkarimi.iut@gmail.com, and this email is written in description. I'm glad to answer your questions. Let's etch this PCB and come back. Okay guys, I etched the PCB and it's ready to make the holes. I drilled the holes with 0.8 millimeters and the bigger ones with 1 millimeter. Let's do it. Okay guys, I drilled the holes and all the holes are ready. We can put the components now on the board, and step by step I tell you which component should be placed where. Let's do it. Okay friends, these are the components needed to make this SMPS, and let's start. The start and beginning of the placing of the components is here in the middle and bottom, and we put a terminal. We have a terminal to connect the AC wires. Let's do it. Okay, this is the terminal, and after that we should use a diode, 5 amperes diode, and it is placed beside the terminal. After the fuse, we need a capacitor, 1 microfarad capacitor and 275 volts. It is called 105, and we should place it here by the fuse. After this capacitor, we should place an NTC. We have a NTC. This is our NTC, and it is 5D9. It is placed here by the capacitor. After that, we need a line filter, an EMI. This is a EMI line filter, and it is placed here. 4 holes are for this EMI. Let's place it. Next part is a bridge diode. We need a bridge diode, at least 8 amperes. This one is JBJ 1010, and it is 10 amperes, 100 volts, and it has a positive side. This is the positive side, and this is the positive pin. We should place in order that the positive side here, the positive side should be inside the PCB, the board, and put it in this manner. Okay guys, be careful. This is the positive pin. After that, we have 2 resistors, 100 kilo ohm resistors, and we place here. Okay guys, I placed the resistors, and now we should place 2 capacitors. These are 330 microfarad and 200 volts. We need 2 of them, and I took them from an old ATX power supply. These capacitors and this capacitor, 1 microfarad capacitor, fuse line filter, and the bridge diode was taken from an old ATX power supply. We should place the capacitors in a way that the positive pin next to the bridge diode, the positive should be here, and the negative the other side, and the other capacitor is like this, positive in direction to the bridge, and the negative pin is to the outside. Let's place them. After the capacitors, we have another capacitor, 1 microfarad capacitor, 275 volts. This is should be placed here, and beside the capacitor we have two holes here. We should place a jumper here, and I have a jumper. First place the jumper and then the capacitor. The jumper is here, and this is the capacitor. Okay, after that we place the components for the hot part, and a transformer here and the cold part here. Let's do it. Okay guys, for continue the placing the components, we have some components here, these three holes, and these are for MOSFETs, but we start from here. We have a Zener diode 15 volts, Zener diode 15 volts, and the cathode should be down. After that we have a diode DB3, and then a resistor 10 ohm resistor. Let's place this. As you can see, I placed a Zener diode 15 volts. The cathode is down, and this is a DB3 diode and a 10 ohm resistor. After that, horizontally we place a Zener diode 15 volts Zener diode. The cathode should be right, and here under the Zener we have a capacitor 47 nanofarads, and here FR107. This is a fast diode, and let's place this three. Okay, I placed here a 15 volts Zener diode, and the cathode is to the right. A 47 nanofarad capacitor, 100 volts, and FR107 fast diode. The cathode is to the right. After that, we place four components here. First, we place a 10 ohm resistor and two 15 volt Zener diodes, which the cathode is to the down, and a resistor here which is 680 kilo ohms, 680 kilo ohms. Okay guys, I placed these four components, a 10 ohm resistor, two 15 volts diode, and a resistor which is 680 kilo ohms. After this, we should place two MOSFETs here, IRFP460 or 20N60, 12N60. All these MOSFETs are suitable for this circuit, and we have two transformers here, two switching transformer, the main switching transformer, and the pulse transformer. First, I teach you how to wind this pulse transformer. After that, the main transformer. Let's do it. Okay guys, now we want to wind the pulse transformer which is the heart of this circuit, and this transformer makes the pulses for the MOSFETs. This is very important, and if you make a mistake in winding this transformer, your circuit will not work. And this is a 25 millimeters ferrite core transformer. This length is about 25 millimeters, and we wind the three windings. First 12 turns, the second one is 12 turns too, and the third one is 100 turns. This is the bowing, and we want to wind around this. First of all, it has four corners. Cut a corner, and this is the corner number one. Three windings should be wound from three start points. Consider this corner. The first winding should be wound and should be started from here. This is start point number one, 12 turns, and on the other hand, this corner is the starting point for the second transformer. The middle at the back, this point is the third starting point, which we wound about 100 turns. Okay guys, so we have three starting points. This pin, this corner is number one, this corner is number two, and the third point is here. We wound first two windings with 12 turns. Let's start. This wire is 0.3 millimeters, and we wind the windings with this wire. As I told you, this is the cut to corner, so this is the first starting point, so we start from here and turn 12 volt. Okay friend, I wound cut corner starting point here. I wound 12 turns, started from here and finished here. Excuse me, here. These 2 points, I started here and finished here, and then now I want to start winding from here and finishing here. Okay, I wound the second winding. Now this is the cut corner, so we start from the middle here and we finish on the other side here. Before winding the third, we should insulate with an insulation tape here. Insulate 6 layers. After that, wind the third winding, which is 100 turns. Okay friends, I wound the third winding and it's now ready to use in the circuit. And before that, don't forget to solder these pins, and after soldering, insulate and replace the ferrite core and use it in the board. Okay friends, now we place 470 picofarad or 471 capacitor, 1 kilovolt, and a resistor which is between 1 kilo ohm to 2.2 kilo ohms. Another capacitor which is 1 nanofarad and 1 kilovolts is here, which 100 ohm resistor 2 watts or 3 watts is here. At first I place 470 picofarad capacitor 1 kilovolt here, and the resistor which is 1.5 kilo ohms. Okay, as you see, I put a 470 picofarad 1 kilovolt capacitor here and 1.5 kilo ohm resistor here. 1 nanofarad 1 kilovolt capacitor and 103 watts resistor here. Okay, as you see, 102 or 1 nanofarad capacitor 1 kilovolt and 100 ohms. Now we place the pulse transformer here, which the cut corner is here. The cut corner should be here. Okay, this is the pulse transformer, it is here. And now we should test this part of the circuit. For the test we use a switching transformer from an old power ATX power supply. This is a switching from the power supply. This side with 2 pins is the input, and here with 6 or 7 pins is output. We use the input, so take 2 wires and connect these 2 pins to these 2 holes. Here is the primary winding or input winding of the main transformer. So a wire from here to and a wire from the other pin to here. Let's do it. Okay guys, as you can see, I have connected the board to a switching transformer of an old ATX, which I have connected these 2 points, this point and this point, to a input pins of the transformer. And on the output we have 2 pins which are connected together. This is the ground pins. These in my transformer, and it is different in any type of transformer. In my transformer these 2 pins are connected together, and so this is the ground pins, and the other pins are the voltages, different voltages. I have connected a car lamp, 21 watts car lamp, 12 volt to the ground, and one of these pins, it is not important which pin you choose, and another lamp, 60 watts lamp, is connected in series with my board. The AC is series with my board and a lamp. So let's test. As you can see, when I power the board, my lamp is on, and this means the board is correct, and we can continue for the rest of the board. Let's test another one. Okay, the lamp is on and everything is okay. Let's go. Okay friends, now we want to find the main transformer, our main switching transformer. We need a EE42 transformer, ferrite core transformer. This length is 42 millimeters, and it has a bobbin. For the primary winding we should use 15 wires in parallel, like this, 15 wires of 0.3 millimeters, and we wind 26 turns for the primary, but note that first we should wind 13 turns, and after the 13 turns we should take the wire outside and wind the secondary winding, and then wind the rest of 13 turns, the second half of the primary winding. In this case I have wound 13 turns started from this point, and I keep the wire outside. Now we go to the secondary and wind the secondary winding. These point and this point and this point, these 2 points are the starting points, and both should finish at the middle here. So let's start the winding. First we wind 6.5 volts per turn. So I want my SMPS to be a 75 volts. So I turn 12 turns. I noted that 6.5 volts per turn. So I wind 12 turns to get about 75 volts. Okay, let's start. For the first winding of the secondary, we use 25 wires in parallel of 0.3 millimeters. Start from here. We wind 12 turns to get 75 volts. So as you can see, I wound 12 turns and now insulated with a tape 6 layers. As you can see, I wound the first secondary and I insulated it. Now the second secondary winding started from here. It starts from here. The starting point is here. The first winding of secondary wounded clockwise. Now the second part of the secondary winding should be counterclockwise. Started from here to this side. The second one starts from here and to this side. So we wind counterclockwise until 12 turns, and we finish here. Okay guys, I wind both secondary windings. One winding from here started from here, finished here. The second one started from here and finished here. The most important notice is that one winding is clockwise and the other one counterclockwise. After you finish the secondary windings, go back to the primary and wind the second half of the primary, which is 13 turns. Okay guys, I finished the primary winding, and after that we have an auxiliary winding which produces 12 volts for fan, for preamplifier, for other uses, and you should start from one of these 2 pins. Start from this pin and turn 2 turns and finish here. You can use 0.5 millimeters or 0.7 millimeters wire. One wire is adequate. After that, your transformer is ready to use on the board. Friends, this is our SMPS, which is connected to this Class D amplifier, and a speaker is connected to the amplifier. The input is here, which is connected to my tablet, and now I want to play a music with it. Okay, I disconnected the input and I can't play any more songs for you, but be sure that this SMPS is very reliable. You can make it very easily, and I hope you make it and enjoy of using it. I'm Hossein Karimi, an electrical engineering from Tehran University, and you can connect me with my email, which is put in the description. I hope you make this and enjoy.